Hey everyone, I wanted to provide a high-level overview for what is Lula to kind of set the stage. Lula is meant to be a validation or compliance engine. Right now that engine is run through a command line interface tool, CLI, but we're really trying to establish a lot of the underpinnings for the code in such a way to be extensible into building out future automation or execution runtime that could be something we do continuous. What is Lula is meant to be a validation engine that augments the compliance process. So Lula utilizes the NIST Open Security Controls Assessment Language framework for how we express our compliance information. So it uses that as the open standard for how you want to capture your data. And also allows you for the ability to place automation inside of that compliance data that can be portable. It can be imported, exported throughout a variety of GRC providers in such a way that the Lula source code only houses essentially wrappers for how to do things in a performative manner, or how to do things with guardrails so that you don't modify the environment inadvertently, and establish read-only workflows, or where necessary, write workflows for samples and testing, but being very explicit in between, and use that in such a way that Lula is not a black box. You don't need to know the source code to understand what is happening in a validation. And so what I've depicted here is essentially what is a single validation. And this is one validation. The thing that I'll note is that for a given regulatory standard, you'll have one to many controls, oftentimes many controls. And for each of those controls, you may need to write one to many validations. And so if we're talking about a standard that has hundreds of controls, each of those controls may have many validations. And you can start to see the scale of which you're starting to provide a process that automates the checking of each of those controls. Historically, the assessment of a control can be something very manual, something very time intensive that takes a human time to perform some activity. The whole goal with a validation is to buy down on automation where we can. So if you are doing everything manually today and you want to start to say, hey, like this is something that we can automate. It's something where I know what I need to check. I know what it needs to adhere to, or the state that it needs to be in. I want to write a validation for that, and kind of cast the vote for, if you start with 1 and you get to 2 and 3, etc. At some point you've gone through the time where I've met 10 out of 200 controls with automation. That 5% is immediately reproducible. If you wanted to get the results of that 5% of controls again, you just rerun it. And within seconds, now you have the assessment of those ones. And so you've bought down on how repeatable and reproducible the process is. And now you can focus on the next 95%, right? And it just continues and continues to buy down on that given standard. But it doesn't have to be a regulatory standard. It could be a STIG. It could be a benchmark. It could also be your own internal policy. If you're an enterprise, your enterprise policy states that you must do these things for the given state of a system or software release, etc. It provides you with the framework in order to set that stage where you have the catalog of intent, and you allow people to meet the intent with how they deem necessary. And what that does is really allows for autonomy within compliance. And so getting back to Lula, we have this foundation for writing one to many validations. To perform a single validation, you essentially define what it is you want to begin to validate. Where does that data exist? And this is where the domain enters the equation. A domain in Lula is essentially a data resource collection process. Right now we support Kubernetes and APIs generically, and it provides some wrappers around how to do that. There's intent to extend these to support other data collection processes. Once you have your data, you will then pass that to your provider. And a provider in this instance is the policy decision maker or decision making engine. Today we have support for Open Policy Agent and Governo, which means you can write your policies in Rego for OPA and the Governo policies, the validating policies for Governo. And so when you've taken your data and you want to validate it, you have a policy that you've written that says, based upon this data, I'm going to ingest that data. I'm going to apply it against this policy. And then if the policy passes, if the result is a pass, then we're going to submit that back to the compliance information reporting. If the policy is a fail, we'll submit that back accordingly. And so that's where you enter those states as specified in the NIST OSCAL assessment results format for satisfied or not satisfied. And there's a lot of layering, there's a lot of override that goes on in between that, and it enables you to have some intro or entry point for how do you want to establish a proof. And once you've got this validation, you can set it up for a piece of software for a given system. You can hand that off to somebody else who's deployed the same piece of software elsewhere, and it's repeatable and reproducible. And so it's reusable, which is extremely important to the conversation. And what we want to do with this is be able to establish better workflows for the accreditation process. Use this to essentially start to automate away how we collect evidence, how we collect a body of evidence that can be reviewed. How do you review it? Is there a role for automation in there? And we very much believe the answer is yes. So in practice, what does this look like? You can see we have a domain. If I'm using the Kubernetes domain in this instance where I'm checking a cluster to ensure that all of the pods are Istio injected for my service mesh MTLS, I would get all the pods. Awesome. Now that I've specified that I have all the pods, you can see this pods identifier here. I'm going to go ahead and pass this data to the provider. In this instance, we have a Rego policy that ingests input.pods, as you see here, pods, input.pods. For every pod, make sure that it is a pod and that it is an allowed pod. And so we check to ensure that they are all Istio injected, and or if they are not, then we also check that they exist in a space that is not Istio injected, such as Cube System, for instance, is not injected for an Istio implementation of a service mesh in Kubernetes. And so what this does is continues to set that stage. Do you want to do this against a STIG? Wonderful. Do you want to do this against infrastructure, cloud, on-prem, etc.? Are there things, is there data to collect? And if yes, then you can start to establish automation around that. And so this is where benchmarks and STIGs are highly effective. This is also where we can continue to produce and share information for compliance from one space to another, make it reusable in such a way that we can focus on validating how you are compliant with given things and focus more so on the risk involved with the governance of our systems, which is ultimately what we are trying to do with compliance and security.